Algebra 1 students, this is the video for section 9.1 example 3. So we're on page 4. So this is 9.1 example 3 video, and we are on page 4 in your note packet. Hopefully the 2 your turns are done down here, but we need to look at jailbreaking when we have variables in our jail along with our numbers. So this is your directions here. So this says the long but surefire way. Jailbreak it. When they talk about it, they mean the variable with the exponent, by writing it out and using the escape partner method. And we're saying this works every time. So remember, g to the 6 means 6 g's all multiplied together. So if I circled my partners, I would say those 2 g's escaped, those 2 g's escaped, and those 2 g's escaped. So outside, I would have 3 g's outside the jail. So that's what's happening here, g, g, and g, which we would write as g to the third. All right, so that's the long way, but it will always work. And it's the exact same method we've been using when you're jailbreaking your number. Now there is a shortcut. It says divide the index. So remember, that's this little number. If you don't see an index, then it's 2. Divide by the index. So what they're saying is take this g to the 6th. And if I take that power of 6 and divide it by the index of 2, I get a 3. So the simplified version, or what would break out, would be 3 g's, or g to the third. So here's another example. I'm doing a third root. So my index is 3 of x to the 12th. 12 divided by 3 is 4. So what would escape would be 4 x's, or x to the 4th. Now this one is a square root, so my index is 2, but if I divide 7 by 2, I get a decimal, 3.5. So in that case, I'm saying, well, I'm going to try to write this as a number of x's that is even, so it's divisible by 2. So I could write x to the 7th as x to the 6th times x to the 1, right? That's equivalent, because if I add the exponents, I get a 7. So if I take this x to the 6th and divide it by 2, 6 divided by 2 is 3. So 3x would escape, and this x would be left. So here's another example of that. If I divide 10 by 3, I get a fraction. But if I write h to the 10 as h to the 9 times h to the 1, 9 divided by 3 is 3, so 3 h's escape, and this h is stuck inside. So let's look at it and give it a try. So I'll show maybe both methods on this. So the first shortcut method would be my index is 2, and 6 divided by 2 would be 3. So that would mean g to the third would be outside the jail. And then I'm going to do it the long way, this method, and then you'll see that that is what we get, g to the third. So you still start by doing your number first. So 162 divided by 2 is 81. 81, if you put 81 divided by 2 in your calculator, 81 divided by 2, you get a decimal. So then remember, you're just going to try 81 divided by 3, and you get an even number. So then 3 and 27. If you try to divide 27 by 2, you're going to get a decimal, but 27 divided by 3 is 9. 9 is the same as 3 times 3. So these are all prime numbers, 2 and 3. Okay, so I am saying, I'm gonna do it right here. A little bit tighter on space in this problem. That 162 is the same as 2 and 3/4. So 2 times 3/4. and 6 G's. So now I'm going to see if I can squeeze in 6 G's. 1, 2, 3, 4, 5, 6. Right small, like I did. Okay, now this is a square root, so I need groups of 2 to break out. So this 2 doesn't have a partner, so I'm going to give that a squiggly underline. This 3 will escape. Here's another group of 2. Only one makes it out alive. Here's a group of 2. Only one G makes it out alive. Here's another group of 2. Only one G makes it out alive. Here's another group of 2. Only one G makes it out alive. So outside the jail, I have 3 times G times G times G. So I have 3 times 3 times G times G times G. And the only thing left in the jail that isn't circled is the 2. So it's really important that you do your circling so you can see very clearly who escaped and who's left. Now simplify, multiply everything outside the jail. 3 times 3 is 9. G times G times G is G to the third. And then the 2 is what is left in the jail. So that's my simplified version. So if you go back up to here when I did the shortcut, when I said G to the 6, 6 divided by 2 is G to the third. That's exactly what I ended up having outside the jail. So if you were using the shortcut method, you would go right to this, and then you would still do the jailbreak on your number. So then you would just have to jailbreak the number. You already did your jailbreak on your variable. Okay, let's try B. So this one, again, I have a negative out front, so I want to make sure I keep track of that. I'm going to think of that as a -1 outside the jail. This is a long tree we end up with here, so on mine I ended up going all the way down here on my paper. So try writing small. So this has an index of 2. If I do 7 divided by 2, I get a decimal. So I'm thinking I want to try the shortcut, but I'm going to rewrite it as 512 h to the 6 times h to the 1. Now remember, if you prefer, you can list the 7 h's and then circle them, but I'm going to show you how this shortcut works. So this h to the 6 divided by 2 is 3, so that means I'm going to have an h to the third that escapes. This h will be left. So now I'm going to say, well, now my problem looks like this. Negative h to the third is outside, so there's my negative. Don't forget that. H to the third escaped. And now what I have is 512 h to the 1. Because this h is stuck inside. Okay, now we got to do a big old tree on this. This is 2 times 256. 256 is 2 times 128. 128 is 2 times 64. 64 is 2 times 32. 32 is 2 times 16. So maybe what you might want to do is draw a line here so you know all this is with this problem. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. It's quite the tree we have. I'm going to slide my paper up here. Okay, let's count up these 2's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, all these numbers I'm not using because those are not prime. Okay, so now let's see what our problem looks like. We still have the negative and the h to the third on the outside. 512 is the same as 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And don't forget that H. Oh my goodness, you can't even see that. There we go. Give you a minute to write that. Pause maybe and write that. Now let's circle our partners. They escape, one makes it out alive. These two twos escape, one makes it out alive. These two twos escape, one makes it out alive. These two twos escape, one makes it out alive. That 2 and that h are stuck in jail. So now outside the jail, I have negative h to the third times 4 2's. 1, 2, 3, 4. Inside the jail, I have a 2 and an h. Okay, this is 2 times 2 times 2 times 2, which is not 8. It's actually 16. So put in your calculator 2 times 2 times 2 times 2. So I have negative h to the third times 16. And in the jail, I have 2h. Now, normally we write the coefficient in front. So this would be negative 16 h to the third power square root of 2h. Ooh, that's a big one. Okay, that's example 3. So now what I would like you to try is right on the same page, finish this your turn. Try C and D. So pause the video and try C and D. So for C, you should have gotten 7x times the square root of x. And for D, you should have gotten 5. Oh, those are n's. I put x's. 5n squared. And what was left in jail is not a 3x, a 3n. Okay, if you need to see the trees, you might have discovered when you were treeing 49 that 2 does not go into 49. 49 divided by 2, I get a decimal. 49 divided by 3, I get a decimal. If you keep dividing, you're going to get all the way to 7. 49 is 7 times 7. So this is the same as 7 times x times x times x. When it's just a low number of x's, I just list them. So 7 escapes, and 1x from that pair escape. So outside the jail, I have 7x, and inside, I have 1x left. So that's my answer there. And then 75, you probably discovered that 3 goes into 75. It's 3 times 25. And then 5 times 5. And 5 n's. So then if you did a jailbreak on 3, those are my prime numbers, 3 times 5 times 5, and 1, 2, 3, 4, 5 n's. This is what you would get for your final answer. Doubles there, so a 5 would escape. These 2 n's, 1 would make it out alive. And these 2 n's, 1 would make it out alive. What's stuck inside is a 3 and an n. Okay, that is the end of this video for example 3.